Well, welcome. This is our second attempt at behavior-driven development with robots. I think I've got all the kinks worked out, but if you were here, I think it was last week, and saw all the technical stuff that goes on behind the scenes, this one has even a lot more of that, of trying to get document cameras and stuff to work. So we're going to go for it. I think we'll be good this time. I think we've solved the firmware problem. I don't have it on the schedule yet, but coming up, you'll get an invite later on today for What is Kanban, which is going to be coming up next week. That's what we're going to be talking about. Just kind of a heads up, what we're going to be looking at is what Kanban is, how to look at creating flow and how to represent work. But one of the big things we want to do is just not try to convince you if you're using Scrum that you need to switch to Kanban, but to understand maybe some of the things that you could pull from Kanban if it's useful. If there's something where you're looking at and saying, hey, you know what, if we could do X, Y, and Z, that'd be a nice thing to add on to what we're doing now. So it's not trying to get you to change your mind about using Scrum if you're using Scrum. Our big goal is just try to help people know other techniques that are out there to enhance what they're doing today. Okay, behavior-driven development with robots. So we've got the robots here, and they were working as of a few minutes ago. But first, I want to just kind of talk a little bit about behavior-driven development, just make sure we're on the same page of what we're trying to accomplish here. We are simulating what you would have in a company if you're trying to do behavior-driven development. So some of it's going to be some shortcuts to make this work, but I want to make sure we kind of have the big picture of what we're trying to do. So behavior-driven development, and the example we're going to be using is in Cucumber. If you're doing behavior-driven development, you have to ask yourself, what is the smallest usable feature that would be closer to a working system? And you'll see that played out with the robots when we get to the maze that we're going to be going through. You define the desired behavior as an example. You make that example executable, and we're going to find a way to make an example executable, just a piece of a maze in a way that we can execute it. And then we're going to make sure that example fails. And then we're going to use TDD to make those examples pass. Now, in this simulation, we're skipping the TDD part. I don't have a great way to do that with the robots yet, but I'm working on it. So if we think of a lot of times in development work, you have our business owner language, and then we've got our developer language. And sometimes those things are a little bit separate, maybe more separate than they should be, because the business talks about things one way and the developers talk about things another way. What Cucumber is trying to do, and the Gherkin language is trying to say, let's create an overlap to where we've got the same language for talking about stuff so we can be really, really efficient at defining how things, how we want the system to work. I saw a conversation the other day. It was somebody saying, yes, AI is going to replace everybody's going to be able to be a programmer because you're going to be able to tell AI what do you want it to do and it will just spit out the code and stuff. And I'm sure there's going to be some great advances in artificial intelligence, but and somebody's comment back to that was, you're saying this as if the hard part of programming isn't figuring out how to just give your specification, right? Maybe we have to write less code, but the art and skill of being able to specify exactly what something needs to do is always going to be with us. And that's what the Gherkin language does, and BDD together work to try to make it easier to specify and combine the domain knowledge from the developers and the business in order to figure out exactly what's supposed to happen. So here's an example. Given I am not an admin user, when I log into the system, then I cannot see the admin menu. Okay, that's very simple, explains what we expect to have happen. And the reverse of that, given I am an admin user, when I log into the system, then I can see the admin menu. And we would take those things, those would be the scenarios, we'd watch it fail, make them executable, write the code, and then eventually the scenario should pass. Now, an important aspect of behavior-driven development is the three amigos, or I like to think of them as the three hats. Matter of fact, I brought some different hats here in case we need to illustrate them, the idea of different hats. So here we go, right here. Okay, so we got these different hats that represent different aspects of what we want to bring to this process of defining what the software is supposed to do. We have the developer hat, we have the quality hat, the tester hat, and then we've got the business hat. And so as we're going through this, we ought to be, as we're going through this with the robot, we're going to try to ask questions that will make sure we're thinking about which hat we're on. Are we thinking of this as a developer? Are we thinking of this as somebody in testing, or somebody on the business side of things? A common anti-pattern in behavior-driven development is to leave out one of these hats. As far as the hat, maybe, I'm not sure. My kids have a lot of interesting costumes, and I'm not sure exactly what I got. So I've got a little collection here of different hats to illustrate this with. So An anti-pattern is leaving out one of the hats. So saying, oh, you know what? Well, the tester and the business is going to get together to decide how to do this, but we don't need the developers there. Or the developers are going to get together with the business, but we're not going to have the tester there. If you try to take that as a shortcut, you cut out a lot of the value of behavior-driven development. In fact, for a lot of people, cutting that out, leaving that out, if you had to leave out something, making it executable may be the most efficient thing to leave out, because that collaboration is really where the power comes in behavior-driven development. I mentioned this before, don't overvalue the artifact. We're going to be working on something here. We're going to get this piece of paper. The piece of paper isn't what's valuable. It's the thought process behind it. I'll skip through these. That's more on TDD. So behavior-driven development, when you finish, you end up with a bunch of tests that can be used as regression tests against your application. But it's really helpful to think of those as regression tests as being a very valuable side effect of the collaborative process of doing behavior-driven development. If you get too focused on the idea of you're just trying to create tests, you do them in a very, very different way. And the teams I've seen that are really, really focused on using behavior-driven development as a way to create regression tests, sometimes they have great value. Sometimes they actually get some value out of it, but the value is the same that they would have gotten had they just focused on test-driven development, because it makes you kind of skip that, skip the collaborative part of things. So here's so as we get in this, one thing I want to mention is, how do you train a team on behavior-driven development? So our goal is always, you've probably seen the slide notes from some of my other talks, but rapid and safe delivery of value, right? That's the goal of any software team. If we want to have rapid and safe delivery of value, we're going to have build automation, continuous integration. We're not going to be able to do things quickly and safely if we don't invest in that. But we're also not going to be able to invest in automating something unless we've invested in behavior-driven development and test-driven development, right? We've got to have something that actually gets automatically run. DevOps would be another part here as well. But BDD and TDD rely on having story creation and sizing and being able to make small changes to our application and having kind of that agile discipline of being able to make small changes as we go. And all that is based on the basic agile values and principles. And one thing that I've seen teams get in trouble is when they kind of come into this and decide, we just want to do behavior-driven development, but we're not going to worry about any of the things that will take advantage of it, so the things higher in the stack, and we're not going to invest in anything lower in the stack. And so as we go through this, really see it as part of a series of things that can work together to deliver the rapid, safe delivery of value, not something that you can just say, hey, we're just going to do this and nothing else that needs to happen as part of it. Okay, so this is on the topic of how do you train a team for behavior-driven development. So that previous slide there is making sure that we're addressing all of these things and how they're all going to improve together. Then generally what I do with teams is I'll want to get some type of behavior-driven development foundation that's focused, that everybody on the team that's going to be involved in it works with, whether it's the management, the developers, the business, whether they code or not. We go through Agile principles and behavior-driven development, how those things work together. We talk about how behavior-driven development can enable courageous software delivery, or delivering with lower risk, but delivering quickly. Another session on what is behavior-driven development, which we did a few weeks ago here. And then this session right here, behavior-driven development with robots, where we team people up in groups of 3 and let them actually go through and mimic what you're going to see here today. Then we go a little bit deeper with the people that know how to code and do some live coding. I've got a test scenario we go through with that. Also do some test-driven development, letting live coding and demonstrate how to do that. Then we go back and do the same 2 things again, but actually a workshop where they get to do it hands-on in whatever programming language they're used to using, both on the BDD side and the test-driven development side of things. And then for the business and leadership and the people that don't code, we usually try to cover leading behavior-driven development on Agile teams. That's a training session I have. Delivery flow simulation. That's aimed more at business and leadership, but is also useful for anyone. Just how do we think about how flow moves through a system? We'll talk about some of this next week in the Kanban, but not do the simulation. And then look at how you can use behavior-driven development to lower the cost of delay. So that's kind of a big, broad picture of how what we're looking at kind of fits into what what I've seen a successful way of getting a team from not using BDD to starting to use BDD and getting value from it. Okay, so here's the parts that we're going to be looking at here today. We're going to be looking at, when we write our scenarios, we're going to write them as a feature file. We're going to be doing it on a piece of paper here. I'll give you a preview here what we're going to be looking at. So here's our piece of paper. I've got markers here. Over on the left side of the screen is where we're going to be doing with the programming stuff, and then we're going to be using a maze over here that I'll grab in just a minute. Okay, so our feature file is going to be, here's how we're defining what the work needs to be. The steps file normally would be the backing code. So like we're writing in Java, we may have the backing code that tells it how to do the things we described in the feature file. Well, for our simulation, we're just going to create pieces of the maze, and that's going to be our steps file. That's how we can actually execute and show whether the robot does what it's supposed to or not. And then the red down here is the program, and our program is going to be written in this language over here. It's a very, you may have seen this if your kids do anything with robots or programming in school. It's a very simple language that is mostly visible. So even if you're not great at reading code, this should be pretty easy to follow along with. So those are the pieces, plain English examples, the examples backing code, which we're going to do through colored markers, and then the actual application. Okay, so that covers what I wanted to kind of do as an intro. Let's see, everybody wants to see the robots now. So these robots, I've got a backup one over there charging just in case something goes wrong. These are called Ozobots. They're about the size of a quarter. On the front of it, you can see there are some sonar sensor. Is it sonar? Yeah, sensors that will tell you if it's getting close to something. On the bottom are a series of things that will read and tell if you're on a line. And there's two wheels, and it can chirp and beep, and I think it might have a mic. I haven't ever used that part of it, and then it just charges on the back of it. So let's try something really simple here. We're going to try just a silly program. We're going to make it move forward 3 steps, and then skate. So go into squiggly line and then spin. So let's try that right now and just see. So first I'm going to turn it on and try to connect to it. I think that's my backup one. I think F4 is this one. So I'm going to pair and send it to this one. Okay, it says it's up to date, and that was the part I was having problems with a few weeks ago. Okay, the squiggle, and it's going to spin. Okay, so it executed the program, so I'm able to send a program to this. And just to make sure everything's working as expected, let's have it do something else because I ran that before. Let's do that, and then we'll do police car lights, and then we'll do fireworks. That sounds like a good thing to see what it does. And then we'll do another spin. Can I duplicate these? Okay, so now this will let us know if we're able to change it. I'll run that program. It looks the same so far. Okay, there's police lights, and that's the disco, I guess. Okay, cool. I don't know if it's just flashing or if it's doing something based on audio, but anyway, okay, we were able to put a program on it and update it. Oh, hang on. They have sometimes tried to run themselves off the side of the table, which isn't very safe for them. Okay, give me just a second. I just had something come on that I want to turn off on the other side of the room. No, it's summer because the dehumidifier is starting to kick on. Okay, so let's get started here. Let's follow our process. So here is our maze. Let me show you the maze that we're going to be working with. And then we'll figure out how to break it down into something that we can program. Sorry, I thought I had this out earlier, but I must have misplaced it. By the way, has anyone, who makes the robots? These are Ozobots. I've had these for a while, and they've been more robust than I had expected them to be. So let's look at some mazes here. So here's an example of the maze we're going to be working with, right? We need to get from here to here, and we're going to use the color of the intersections to figure it out. Now this is another maze that in some of the classes I've done that's a little bit more advanced where you've got to jump from one line to another. But as basically, this is, since it's a line following robot, this is what we're going to want to follow. So let's so if this is our maze, we need to figure out a way through the maze. Now we could do something like say, okay, turn. No, that wouldn't work. I was thinking this would work. So we could say something like, okay, we enter the maze, and let's just take left-hand turns or right-hand turns. So if I turn right here, I turn here and follow this, that might potentially get us through, but it's probably not going to be very robust as far as following rules, and it's going to be really bad for an example. So we're not going to do that. But there's a couple different ways we could make it through the maze. If we were to come here, so let's assume we want to go left. So we come here, and let's say we want to turn to the right, or turn to the left. So we turn to the left. So we could have a rule that says when I get to red, turn left. An intersection, turn left. Let me mute everybody here for just a second. So if I do that, come here and I turn left. Okay, so that works. And then when I get over here, maybe I want to say when I get to blue, turn right. Okay. If I get here and now I'm turning left again, then maybe that would turn right, and then green would maybe go straight. Different ways through the path. That one I think I might get stuck on here. But the path we're going to take here is to start here. We're going to come into this, and then we're going to turn right. So we go to the right, and then we're going to stick, if we get to blue, we'll go straight. So here, blue, we can go straight. Or actually, let's make it more exciting. Let's do this. When we hit blue, we're going to turn to the left. When we get to green, we're going to go straight. When we get to blue, we go left again. And when we get to red, we'll go right. So we're going to try to take this path through. So this is the thing I said about just going all the way to the right would work, but it's not an optimal path through the maze. Also, if you're looking at getting the robots, look at their website. I think sometimes that may come with more, and you can also sometimes find them on eBay for a good deal if you're looking at doing something like this. Let me mute everybody again. I think somebody keeps coming off mute somehow. Okay, I'll do that again. So watch out for the mute button. Okay, so we're going to try to do this. We're going to try and navigate through the maze like this. So in the chat, what do I need to do when I get to red? What do we decide we need to do when we get to red? So I hit a red intersection. Which direction should I go?
Left.
Well, we're going to actually want to go
right.
We're going to take this. So in this case, we want to go to the right. It's probably a little bit confusing because it's upside down. But think in terms of if you're the robot navigating this, okay? So I now have a rule here of something I want to do. So let me try to express this in, so this is where we'd have our three amigos meeting. Given I'm a robot, so that could be a very valid way to start, right? When I encounter a red line. Thing is, it's not just a red line. There's actually something, the way the robot works is it gets, it'll navigate lines and it can make decision points at intersections. So we're probably going to want to have the word intersection in there. So if I'm putting on my, my tester hat, I might say, well, is there a difference between, this intersection over here is different than the intersection here. And then, so that maybe that was my tester hat. I was going to try to switch out hats, but that's just going to be too much of a pain. So I'm not going to do that. So then the developer hat may come on and say, you know what? We know how the robot works. It doesn't really matter. As long as it's an intersection, we can choose between going straight, going right, or left. And the tester goes, oh, okay. I didn't realize that's how the technology worked. That's great. Then we don't need to differentiate between the types of intersections. Okay, so good. We got that figured out. And the business owner might have been the one saying, hey, I want to make sure, we may have looked at taking a path like this through it. And the business owner said, no, that doesn't look optimal. We actually want to go through here. It should be available on the Agile LnL YouTube page after as soon as this is done. So it should be streaming there right now. So the recording should be there. Okay, so the business and everybody sits together and they talk through this, and then we're like, okay, now we need to write down what we need to do. So given I'm a robot, that could be one. That might be within the scope of what we're doing. So maybe it's not so much, if we're thinking from a robot's point of view, it might be, given I've encountered a, well, okay, so the other piece of this is the robot's just going to follow a line. So maybe I should have something like this. Given I'm just going to shorten it to an intersection. Okay, and our format here is given, when, then. So given an intersection, when, and remember our first one we want to look at here is saying, okay, the line's red. So given an intersection, when the line is red, then what do we want to do? Okay, what did we say? When I red T, turn right. Now keep in mind we're wanting the red T. Yes, the red T will want to turn right. Although this right here doesn't quite look like a T. So we're trying to make our language in a way, we're going to refer to all of these as intersections, whether it's a T or an X, because that will be useful to us if this continued to progress. So given an intersection, when the line is red, then we want to take the right branch, right? So I'm going to say turn right, just to keep it simple. This might be something where the tester would say, are we actually turning right, or are we taking the right branch? There might be discussions around how we want to actually talk through that. In this case, it is a T though. Okay, so given an intersection when the line is red, then turn right. Okay, so let's say everybody agrees. We got our tester, we got our business developer, and we got our developer, and they're like, yes, this represents the behavior that we want to see this robot do when it gets to that first thing. So the developer is going to take that, and the first thing we want to do is make it executable. And making it executable means we need to create something in code that lets us actually execute our code and somehow trigger the code in a way to see what our code does. So anyone think of a way we could possibly do that right here? Yes, it does have a light to see the lines in the dark. These do light up. A good question. Okay, so how can we see, like maybe our robot already does this, it already works. How can we, now we could run it on our, this is production data, right? So we could just turn it loose in here and see what happens, but let's try to find, just for this one piece, how could we test and see if our robot does this to a test script. And you're thinking along the right lines, but we're going to make this even really simple, right? Here is my executable example, right? So I can take my robot and try to run it on this, and we'll see what happens. So if I turn my robot on, put it here, okay, well, it turned to left. That's not what we wanted. Maybe it's just a flaky test, right? So we're going to try it again. Turn it back on. Oh, that time it went straight. It's a really flaky test, right? Maybe we should just run these tests 10 times, and if it passes on any of them, we'll call it good. That time it went straight. Okay, well, our robot does not. We've successfully proved that our robot is not following this scenario right here, which is successful, right? Won't it have trouble at the other intersections if it can't turn right at them all? Yes, and we will get there. So what we're doing is we are saying this is, matter of fact, let me get back here. I'm going to jump back here just to make sure we've got on the same page. So here is, whoops, there is my desktop. That's not what I want to show. Okay, so we have our feature file. In this case, the given intersection, when the line is red, then turn right, that's our feature file. Our example back in code, which normally would be maybe doing something with Selenium or something like that, for us, in our situation here, we're just making our example back in code, or the actual thing that's going to execute against the application, just these lines, right? Just this right here. And it's really simple to do, because all we've got to do is say, well, how does it behave at this intersection? So it doesn't do what we expect. So now what we can do, remember that loop we get into? We have a scenario. Show you the loop again. So we wrote a scenario. It has failed. We made it executable. We found a way to actually execute against that scenario. Now we get to write the code. So that's where we are right now. And you might write all the scenarios all together. We're going to go through them at least the first one on its own. Wouldn't the red cross rather be the concrete test data that the test uses? You might think of it like that, but keep in mind the robot is going to be our code, right? And we have to have some way to test what the robot's going to do when it gets to a red intersection, right? That's what we're trying to do. For the purposes of this simulation, a fun thing with these particular robots, this is the easiest way to do it. And keep in mind, this simulation is set up to be able to do this with people that don't necessarily write code and to get them to experience it. So we can probably find ways that the analogy breaks down, and it does, and that's fine. But we're wanting people to really think through the different parts of it and how it all comes together. But very, very good point. There might be a way to try to do, like, we could try to load something else into the robot to try to test what it does, or we could have an iPad that we would write code that would make the red X appear on it and then keep track of where it is on the iPad. So lots of things like that we could do. This doesn't necessarily need to be an industrial robot for what we're doing here, but good, very, very valid points in what you're talking about. Okay, so let's come over here and let's think of how can we deal with this. So first thing I'm going to do is I'm going to delete all this stuff. Can I select more? No, I guess I've got to leave them one at a time. There probably is a way to do more than one. Okay, so I happen to know so just kind of how this programming environment works. There are very simple programming things here. If you notice, these don't even use words in them. But as I go up to different levels, I get increasingly complex commands. Like I've got different things I can do. And this works really well for the classroom if you're working with kindergartners or something. You don't want to them have to deal with complex loops and things like that. And I think for what we need here, we're going to actually have to be on level 5. Okay, so what are our options for movement? So let's see if we can figure out some way to handle this plus right here. So line navigation, that looks promising. So let's see. So, well, this seems good. Follow the line to the next intersection. That sounds like something we might want to do. And then what do we do after that? Okay. Maybe we want to... Okay, we can pick a direction here. But I could pick a direction and just go right every time. And I might do that as a way just to get started, but that's probably not getting me. I need some way to figure out what to do if it's a color. So I want to get the can I just get the surface color here? This one doesn't get the surface color, so you're right. I need to look for something else. Let's see what my options are here. The variables, don't think any of variable. There's loops, logic. Let's see what I've got with logic. So I may want to have a logic thing over here, so I'm going to drag that out there. Look here. And all we're going to be using are the color sensors right here. Sounds, buttons, timings, terminate.
Isn't it the bottom one in the list in line navigation? Is that what you're looking for?
It may be. Let's look. So in line navigation, right here, intersection line color. Oh, you're right here. Okay. Yes, very good. So I can get the line color. That lets me do that. And then I can come over here and decide what color I want to do. So I'm probably going to need some type of if. So maybe that would be equal. So maybe I want to do like this. So I want to say if the intersection or into the line color equals red, and this doesn't go in there, just kind of put it there. Okay, so get the intersection line color. If it equals red, then I want to, can I choose, then I want to pick the direction and go to the right. All right. And this probably needs to go up here, right? I need to follow this to the next line. So that looks, I think that looks pretty good. Okay, so let's walk through it. We're going to follow it to the next intersection or line in. When we get to the line in, we're going to get the intersection line in color, and if equals red, then we're going to pick the direction and go to the right. So let's see if this gets us different behavior than what we were seeing a minute ago. Okay, am I on? No. I think I turned it off. So I'll try to turn it on again. There it is. I remember it's the F4 one. And I'm going to set it right there. Oh, did I send it yet? I don't think I sent it yet. Let me, okay, let's run the program. Run. Okay. Well, that's not what I expected to see happen. Let's try it again. Okay, so something's not doing quite what I expected here. So let's take a look. Okay, and I'm going to grab something right, this other robot in case I need it. Okay, so I got to the line end, and I just stopped. Okay, so my program's there's no further action statement. Oh, you're right, it didn't do anything. Very good, so let's see what happens if we do this. As a matter of fact, let's do this. Let's try to wrap, and then we'll start with that. So let's duplicate this block. It got there, okay, so our hypothesis is it got to the end of the thing and then was like, oh, I turned right. I picked the direction right, but I didn't actually do anything with it. So let's see if we see this pair programming. This is truly mob programming, right? We've got like 105 people here working on this. Okay, so we're going to run the program. No, didn't work that time. I don't think I actually uploaded it though. So let me get out of here. Okay. And this did work the other day, so let me see. Did I mess up something? What do you think? What did it do wrong? It's showing that's not saved. Okay. I think it's saying it's saved as. Okay, so now I've saved the program, which is always important to do. Okay, so I've got this. I'm going to run the program. Star in the name. I think I got rid of it there, so I think that's clear now. Okay, well, let me do something else here. I see one thing. We may not be. I'm going to try to put this whole thing in a loop. Matter of fact, we'll just do this. A simple like this. Okay. And I'm going to remove this one. Okay, so follow the next line ending, get the color. If it equals red, then pick the direction right. Let's go over here and all right, let me turn the robot off and back on just to make sure we're completely clear. So we'll connect. Okay, that did what I expected that time. Although it's saying connection failed, so maybe it was random. Let's go and choose this one. Okay, says the robot is up to date. So let me put it over here again. We'll run the program. And it's not doing what I was expecting. So let's try this again here. Stop program, run program. There we go. Okay, we read it correctly there. Then stop it. We'll run it again. It may not be quite on the line. Okay, so it looks like we're passing this particular scenario. There it is again. Okay, so we got this scenario passed. Whoops, missed the line. Okay, so we passed a scenario. So what's the next scenario we're going to want to do? Intro to programming, yes. And if you want to experience programming in a way where everything that can go wrong does go wrong, try it with something in the physical world. Always celebrate, yes. Okay, so here, that was our first one. The next one is blue. And remember, we want the optimal path through here. So what do we want to do at the blue one? Declare it done and push it to production. Okay, well, we may want more than one scenario before we push it to production, or our robot's going to just blow up when it gets to the line it doesn't recognize. If blue, turn left. Okay, right. So I'm going to do that here. So given when the line is blue, then turn. Let's see. Then we want to turn left is what we said, right? We're correct? Okay. So now let's get... So we talk about this. The developers are saying, yep, that sounds good. We think that will work in this case. The tester says we think this will work in that case. The business is, yes, that's indeed what we want to do because that's the path we want to take through here. That will be the optimal path through this. So now the developer is going to go up and come up with a way to actually make this executable. I'm going to make this a little bit longer this time at the bottom. Okay. So we've now got that, and we expect it to turn. So let's, first thing we're going to do is we're going to run our program here. Actually, I think that's running just the default line following. So I'm going to turn it on and connect to it and load the program that we've had so far to it. Because I want to see what it does when it gets to a line if it doesn't know what to do, right? So we'll run the program. Maybe it just goes straight on through. It just ignores it. Okay, so with the blue, it's just going right on through. And I guess that makes sense, though, because if we look over what we're doing here, we are saying follow the line to the next line in. If it's blue, pick right, and then loop back over. So it's going to come right back over and do this again. So it's just going to keep on going to the next line. If it doesn't understand the color, it's just going to keep on going straight through. Okay, so we've proved that it does not know how to handle the color blue yet. So now we can jump over to our programming. And this should be pretty straightforward. We probably just need to duplicate this, right? If I duplicate this right here, set this to blue, and we said we wanted to pick the direction left. Okay, so now let's see if this works for us now. No, hang on, I didn't get connected to it yet. I wish there was a way to turn off any default behavior so it doesn't surprise you. But it's more fun having some robots that surprise you, I suppose. That didn't do as expected. Okay, that one did. Let's see. Okay. Okay, and let's see if it still works on this one. Okay, there we've got a regression test. It still remembers how to do that. Still remembers how to do this. Oops. And what happens if we come from a different angle on it, like that? Okay, so it looks like we've handled blue. Now, what did we want to do? Uh-oh, we've got another blue here. Or we've got another green. Now we've got a green here. So we might ask ourselves, what will it do with green by default? And I think we decided it's probably going to go ahead and go right through it. Okay, so now we could probably say, okay, we don't need to worry about that one. But then the quality person might put on the quality hat and say, hey, wait a minute, we probably need to go ahead and say explicitly what it's doing, because when we come back to look at this later, we're going to want to know. And if we don't say anything, if we just say do nothing, what if we eventually have a more complex maze and we tell green to do something else? Well, then it would break this, but we wouldn't know about it. So that would be a good reason for the testing hat to be thinking there and saying, okay, so given an intersection when the line is green, then turn, whoops, I don't want turn, I want then go straight. But that little simulated conversation there of talking about how the business, oops, you couldn't see that as I was doing it, about how those conversations should take place is really, while it seemed like maybe just a side note, that's really the key thing that's happening in behavior-driven development, is having those conversations and saying, oh no, we really do want to have a scenario for this because of what we know about things are going to change in the future, or just what we know from testing, or all those types of things. Because if you just have a developer making the decisions, or you just have somebody, you just have the developers making the decisions, or just have the business making the decisions and throwing it over to the developers, you miss a lot of that context that comes from really just talking through these. Now, my guess is, right here, if I connect to this, it's probably going to do exactly what we expect, even though we haven't programmed anything. And then this one still works. Okay, and this one still works. So now what's interesting about this is the behavior. Is the red one not working? Let's see. There we go. Okay. What's interesting about this is we may have the behavior that we expect, but we haven't really written any code for it. So what I would usually encourage teams to do at this point right here is we don't have a failure. Until we're able to see a failure, we don't know that we've actually written code to make this pass. So I would probably encourage teams to do something like this. So I'm going to duplicate this, and then I'm going to put some code in here just to have a failure that says when this is green, I want to go back, right? That would be pretty dramatic. So let's make sure that we can actually get a failure here of it not doing. So when we change the code and it then does what we want, we can see it. Okay, so I'm going to say run the program. That didn't do what I expected. Okay, so I'm not, what am I running into here? So we're going to line ending, and we're saying if it's green, we expect to go back. Well, let's see. I'm going to try this again. We may be running into a problem with my marker's color not being quite aligned with what it's expecting. But I've got another way to test that if we need to. Okay, let's run the program. And it's just going straight through. Let me grab this over here because this is printed with the same printer, and sometimes we have things that are slightly different colors of green. There we go. Okay, so it has to do, I've discovered that there's a difference in my testing environment. My testing harness is not doing exactly what I want. But if you notice what this is doing is when it gets, this is just going to go in a loop. But the good thing about this is I've proved that I've got the program, what my program is saying the robot's actually doing. So now if I modify it, and actually this will be good because it's just stuck in a loop. If I come over here and modify this and say I want to go straight, robot's struggling with anxiety. Yes, it's lost. Okay, now it's going straight, right? And this one here goes the way we expect. And this one here turns what we expect. Okay, so we now have the three things this needs to do. This one, my color isn't quite right. I guess I had other Sharpies last time I did this. But I think we're in a way, we've actually gone through all the scenarios and they all seem to do what we expect. So we're probably in a good place now. It says follow line next intersection or the end of the line. Is there code for each of those? Let's see. I think it's just saying go till you need to make a decision. If you just got a straight line running around, then you don't have to make a decision on it. So let's put this here and let's go ahead and run our program and let's see if we navigate successfully through the maze. Okay, so if we just ran all of our code and it made it through the maze, what's the next thing we probably should do? So we made it. Celebrate. Yes, we should definitely celebrate. I think that's a great one. Another thing that we might want to do is run it again, right? Let's make sure it wasn't a fluke. Yay, so we made it through the maze. So that seems to be working. We could potentially try to find a way. Let's see, is there a intersection line end? I was going to see if there's a way you could tell that you were actually at the end of the maze. The robot rebellion starts when the lights are off. So we can also do some interesting things here if we wanted to. These are things that would be harder to test for, but we could set the color of the light on top to be whatever color we happen to have last seen. Let's duplicate that. Now, this brings up something interesting. If you're working with behavior-driven development, first of all, let's see if it works. Oh, it's gonna go back to its program. Let's stop it. Okay, see how the light turned red? Now it's blue. Should have turned green there. Did not turn green there for some reason. We're back to red. So I'm not sure if we're having trouble with the color, or maybe I didn't set it right over here. Let's see. Yeah, for some reason that didn't work. But the point I was going to make with it, here, I'll try it one more time here, is this would be something that, given our environment here, would be very, very difficult to try to test, right? It'd be very hard for us to write some tests. I'm not sure why that green one isn't coming through. Although I've got suspicion, what happens if I do this? I put that up at the top. Let me send it again. We got the red, we got the blue. Oh, for some reason it just doesn't want to set its light to green. But the question the reason I was doing it, what I was wanting to show was, actually, now I'm just really curious. What if I set it to the other green line? It seems darker. Oh, you're saying that maybe I've got the wrong, there's only one green color for the line. That's a good idea though. Let me try this one, and then I'll get to the point that I was actually trying to make. Okay. Let's see. No, something's not working. So what I would normally do here is try it with the other robot, or see, or move some other things around. But the point I wanted to make with that was, this particular piece of the behavior, like what the color is on the top, would be very, very difficult for us to test in our current environment. That would be a very hard thing to try to come up with the test. But it's also something, so you may have a conversation with the business and say, hey, you know what? It's going to take a huge amount of engineering effort to get to where we can actually figure out what color the light is on top of it, on these things. Is that something that we really need to test, or is it enough to just document what it is? What are the consequences if something gets through to production, this doesn't do what it's supposed to? And a lot of times it is very well worth it to build whatever engineering you need, because you're going to have lots of places where you need to check for those things. In some cases, it's not. One of the anti-patterns I've seen people doing with behavior-driven development is trying to use behavior-driven development to describe how things look on the screen. So, given I'm on this page and I look at this button, when I look at this button, then the color of the button is blue and uses a sans serif font. Those probably aren't things you really want to have in your BDD feature file, because it'll obscure all the stuff about how it's actually used. So you're going to be making kind of balances and trade-offs between the functionality and everything you could possibly test. And there's not a right answer for it. But generally, if it has to do with how it looks, those are things that there are probably better ways to test than trying to do in the different ways to test, other than just having them in your behavior-driven development. Okay, so I'm going to be playing with it. Are the colors intentionally faded or faded over time? I think you're talking about this. It has more to do with the way that my light is working, I think, that's on it. Although I'm curious if I do this now. Let's see what that does. I don't know if it'll execute the same program or just do a line following. Okay, that's just doing a random thing. Okay, we'll run the program. Oh, it just doesn't like green. So next time I should use color other than green or something. Or it may be this particular robot is just off. I can actually test it here. Let's try a different robot. Is that one paired? Okay, that one's just driving around randomly. So let's see. If I run the program now, maybe this robot actually does better. There, that one turned green. So this robot, so somebody mentioned maybe it's got a defective light or something. Okay, this one did what we expected. So we tried it. We tried it on different hardware and it behaved differently. Now we've got a big mystery on our hands. Anyway, that covers what I wanted to make sure kind of get through. Hopefully that gives you an idea of kind of how the business and the developers and testers all work together. Yes, works on my machine. These are this exercise I like to do with people because, we kind of struggle through it here, but what's really great is when you get teams together and let, in groups of 3, them all struggle through that and see how it works together. So this is something, I've got a whole fleet of, I think about 20 of these, and I'll come in with clients and we'll sit down and spend a few hours going through this just to get everybody on board of what the BDD process feels like, and you have fun with robots too, right? So if anybody's interested in that in your, something on your Christmas list now, yes. If anyone's interested in something like that for your organization, talk to me and we'll see if we can put something together. It's a little bit hard to do hands-on at a distance, although we have done that before. So, any thoughts, questions? What do you think? Was that helpful?